Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0238, indicates a high voltage condition in the turbocharger boost sensor circuit for the Honda CRV, model years 2017 to 2022. This code specifically concerns the turbocharger boost sensor, which is responsible for measuring the pressure boost produced by the turbocharger. This sensor is typically located near the turbocharger within the engine compartment. It plays a crucial role in providing feedback to the engine control module, ECM, or powertrain control module, PCM, optimizing engine performance and efficiency. High voltage conditions can suggest sensor malfunctions or circuit issues that may affect engine performance, leading to potential drivability problems. Understanding this code is essential for proper diagnosis and repair of the vehicle's forced induction system. The turbocharger boost sensor is a critical component within the Honda CRV's engine management system, tasked with monitoring the pressure of the intake air produced by the turbocharger. As the turbocharger compresses air to improve engine power and efficiency, the boost sensor sends real-time pressure data to the engine's ECM or PCM. This information is vital for the engine control strategies, allowing for precise control of fuel delivery and ignition timing. In most Honda CRV models, the sensor can be found in close proximity to the turbocharger, typically mounted on the intake manifold or the turbo unit itself. If this sensor fails or produces a high voltage signal, it can trigger the DTC P0238, indicating an immediate need for diagnosis and potential replacement to ensure optimal engine performance. Several factors can contribute to the triggering of DTC P0238. A common cause is a faulty turbocharger boost sensor, which may have become inoperative due to age, wear, or damage. Another possible cause is poor electrical connections at the sensor or between the sensor and PCM, which can lead to intermittent voltage signals. Additionally, damaged wiring or open circuits in the sensor's wiring harness can also result in high voltage readings. It is essential to examine these areas carefully during the troubleshooting process, as neglecting to address faulty connections or wiring issues can lead to recurring problems and additional diagnostic trouble codes. Understanding these potential causes sets the foundation for effective troubleshooting and repair. When the DTC P0238 is triggered, drivers may experience several noticeable symptoms associated with reduced engine performance. The vehicle may exhibit sluggish acceleration, indicating a potential lack of boost due to the turbocharger's impaired functionality. In most cases, the check engine light will illuminate on the dashboard, alerting the driver to a fault in the engine management system. Additionally, symptoms such as turbo lag can manifest, where there is a noticeable delay between pressing the accelerator and the engine's response due to inadequate boost pressure being generated. These symptoms not only affect drivability, but can also lead to more severe engine issues if left unaddressed, highlighting the importance of timely diagnostics and repairs. The first troubleshooting step for diagnosing DTC P0238 involves turning the vehicle's ignition to the on mode without starting the engine. This allows the diagnostic tools to access live data from the engine management system. Using the Honda Diagnostic System, HDS, the technician should specifically check the parameters related to the turbocharger boost pressure sensor. The signal should read more than 4.49 volts to confirm proper sensor function. If the reading matches this threshold, it indicates that the circuit is operational, allowing the technician to proceed to the next steps. If the voltage is not within range, it suggests possible intermittent issues, leading to further investigation of connection quality at the turbocharger boost sensor and the PCM. In the second troubleshooting step, The technician must turn the vehicle to the off or lock mode before disconnecting the turbocharger boost sensor 3P connector, which interrupts the circuit for safe testing. A jumper wire is then used to connect terminals A and B of the sensor connector, effectively creating a bypass. The vehicle is switched back to the on mode to recheck the parameter with HDS, specifically looking for a voltage reading exceeding 4.49 volts. If this check shows the required voltage, the technician can safely infer that the circuit is intact and proceed to check for other potential issues. However, if the voltage is not present, it indicates that the turbocharger boost sensor may need replacement, as it might not be functioning correctly. Continuing with the diagnostic process, Step 3 requires the technician to turn the vehicle off once again and remove the jumper wire from the turbocharger boost sensor 3P connector. The next step is to measure the voltage between the designated test points, specifically points 1 and 2, while ensuring the turbocharger boost sensor is disconnected. This measurement should occur with the vehicle in the on mode. The desired reading should be around 5.0 volts, which confirms that the PCM is sending the correct reference voltage to the sensor. If the voltage is as expected, the technician should proceed to further steps to diagnose wiring issues or refer to service manuals as needed. If the reading deviates from this value, it may indicate a fault in the SG2 line or related circuits, necessitating further testing. In the fourth troubleshooting step, the technician must again ensure that the vehicle is in the off or lock mode before jumping the SCS line using the HDS. This action initiates a short circuit simulation, allowing for further diagnostics. After waiting for over a minute, the PCM connector E, 80P, is disconnected to evaluate the circuit continuity between the SG2 line and the corresponding terminals of the boost sensor 3P connector. Continuity should be checked to ensure there are no breaks in the wiring. If continuity is present, it indicates that the SG2 wire is operational, suggesting that the issue lies elsewhere, possibly within the PCM or the turbocharger boost sensor itself. However, if continuity is absent, it confirms an open circuit in the SG2 wire that requires immediate repair. The fifth and final troubleshooting step mirrors the previous steps in its approach. Begin by turning the vehicle to the off mode and again jumping the SCS line through the HDS tool. A minimum wait of 1 minute is necessary before disconnecting the PCM connector E, 80P. The technician will then need to check for continuity between the P3 line and the associated terminals of the turbocharger boost sensor 3P connector. A successful continuity test indicates that the P3 wire is functioning as intended, which directs the technician to explore other service publications or substitute with a known good PCM. Conversely, if no continuity is found, it will be necessary to repair any open in the P3 wire that connects the PCM to the turbocharger boost sensor, ensuring a completed circuit and restoring proper sensor functionality. After completing repairs related to DTC P0238, it is essential to conduct a final verification to ensure that the issue has been fully resolved. Start by clearing all diagnostic trouble codes from the system using the HDS, which resets any flags that were set during the diagnostic process. Next, perform a test drive of the vehicle under various conditions to monitor engine performance and boost response. Observing whether the turbocharger is functioning as expected is key. Acceleration should be smooth, with no signs of lag or hesitation. After confirming that the vehicle operates without triggering the DTC again and boost performance has returned to normal, document the results. This verification step ensures that the problem is thoroughly addressed and helps maintain vehicle reliability moving forward. to prevent future occurrences of DTC P0238 and maintain the longevity of the turbocharger system. Preventive maintenance is crucial. Begin by regularly inspecting the wiring and connectors associated with the turbocharger boost sensor and the PCM. Look for signs of wear, corrosion, or damage that might impact electrical connections. Ensuring that all harnesses and connectors are securely attached and free from contaminants can significantly reduce the likelihood of intermittent faults. Additionally, it is wise to replace the turbocharger boost sensor proactively when it displays signs of degradation or if the vehicle has high mileage. Implementing these preventive measures can help catch potential issues early and maintain optimal engine performance. In summary, DTC P0238 represents a high voltage condition in the turbocharger boost sensor circuit, indicating a potential malfunction. Proper diagnosis involves a systematic approach using the HDS to assess voltage readings and continuity checks within the circuit. This comprehensive troubleshooting guide outlines essential steps to identify whether the fault lies within the turbocharger boost sensor itself or in the associated wiring and connections. By following these diagnostic steps closely, technicians can effectively pinpoint the issue and implement the necessary repairs. Ultimately, proactive maintenance plays a vital role in ensuring the longevity and efficiency of the turbocharged engine, helping to avoid similar problems in the future. Please like and subscribe to the channel. See you next time.